This week, what we want to do is we want to pull data from multiple tables. And in order to do that, we have to join our tables. And the way we join tables is we take the column that has the same data in two different tables, and we connect the tables based on that column. Now, that column is typically a primary key in one of the tables and a foreign key in the second table, the related table. What you need to do is read through the textbook chapter, and then you're going to go through the chapter key points. And this is actually a really important chapter for you to understand because we're going to be using these concepts throughout the semester. And the whole reason that you created a relational database is so that your tables can share data. And the way we share data is we join the tables. So there are different types of joins, and this chapter does cover all of the different types. So the default, if you just use the word join in your select statement, is what's called an inner join. And in an inner join, it is only going to display the data that has the primary key in table 1 matching up to the foreign key in table 2. When they're equal, it displays the row. And I think the easiest way for you guys to understand this is to kind of come down here and look at the example. Here is the syntax. So we use a select, just like we did in chapter 3, and then we say from, and then we give it the name of a table. And that is our table number 1. And then we use the join keyword, and we join it to table number 2. And then how are we connecting those two tables? We are joining them on a column that has the same data in both of the tables. And so in table 1, that column would typically have our primary key. And in table 2, that column would be a foreign key. So looking at this example, we want the order ID and the customer name. And we are going to look at the order table and the customer table. And we only want to see the rows where the customer ID in the order table matches up to the customer ID in the customer table. And that makes perfect sense, right? We want to see the orders that our customers placed. Okay, so this is an inner join. It's only going to show us the orders that the customers placed. Customer ID in this case would be a primary key in the customer table, and in the order table, it would be a foreign key. Okay, but it has the same data. Okay, so customer number 10 in our customer table would correspond to customer ID number 10 in our order table. This next example is a little more complicated because we're dealing with 3 tables instead of 2. You'll notice that we're using a join, so it's an inner join, the most restrictive. And so what we're doing is in our select, we're telling it all of the data we want to see from all 3 tables. So we're saying from the order table, we want order ID. From the customer table, we want customer name. From the shipper table, we want the shipper name. Okay, that's everything we want to see. And you'll notice that the columns are prefixed with the names of the tables. Do you have to prefix the columns with the table name? You only have to do that if the multiple tables have the same column name. For example, if you had an ID column in multiple tables that you were joining, then you have to prefix ID so that SQL knows, which table it should look at. In this case, would we need to have the prefix? It just depends on what the other columns are named in each of these tables. So looking down at the tables, our table 1 is orders. So the first join is looking at orders and customers. And we are retrieving rows where the customer ID in our order table matches up to the customer ID in the customer table. And that's exactly what we did before. We are also going to take order and join it to shipper. So orders remains our table 1. Okay, and then shippers becomes table 2. And then we are matching up on the shipper ID. So in the shippers table, shipper ID is the primary key. In the order table, it is a foreign key. And we're only going to see the rows where they match. Okay, and you can actually run this query and see how it works. Now, you can see if you have long table names, how your queries can get quite long with the prefix of the full table name. So quite often you will see an alias used. So an alias is typically 1 or 2 letters that we designate as a substitute for the name of the table. And where you tell it the alias is in the from clause. So in my from clause, I can say, instead of using the word orders, I'm going to use the lowercase letter o. So I've got from orders as o, that creates an alias. So now anytime I would have put in orders and a dot, I can just use an o and a dot. And then if I'm doing a join, I can do the same thing with the table there. I can give customers an alias of C. So anytime I would say the word customers, I can use the letter C instead. So you can see up here in the select, I've used it, and also in the on clause. That does save you a lot of time typing. So if you're comfortable using aliases, I encourage you to do that because it will make typing out your queries faster. After the inner join, we have a left join. Basically what that does is it pulls in everything from the first table and only the matching data from the second. So in this little example, our table 1 is customers. So what it's going to do is it's going to display all of the customers, even if they have not placed an order. Okay, so we've got the customer name and the order ID, and we are matching them up based on the customer ID. So it's going to show every single customer in the customer table. And if they have not placed an order, it will say null in that column. And we can go out here and run this. I'm not sure if there are going to be any nulls. Oh, yes, there is right off the top. So this is a customer that did not place an order, but because we have a left join, it's pulling in all of our customers. Now, if we change this to an inner join, right? If we change left to the word inner, or we just get rid of left, then those nulls are going to go away because it's only going to display rows where the customer ID is in the customer table and the order table. So left join pulls in everything from table 1, and a right join pulls in everything from table 2. Okay, so even if there's no matching rows in table 1, it's still going to pull it in. In this little example, to me, a right join would be an error because that would indicate that we had an order that did not have a customer. which would be a problem. I would not expect to see any nulls in the customer column. In fact, it won't even let me run it. This would be an error condition. This other example may make a little bit more sense. We've got employees and orders. And so we're going to display the order ID, the employee last name and first name. Our table 1 is orders, and our table 2 is employees. So basically, we are going to be displaying all of the employees, even if they did not assist on an order. Okay, and so here, it's going to be retrieving orders where the employee ID matches what we have in our employee table. Okay, but we very well could have employees that did not help out on any orders. Okay, maybe they weren't working, they were on vacation, whatever. Okay, and so normally you would see a null. For some reason, it's not displaying that, but here we have an employee that did not help on an order. A full join. What this does is it pulls in data from both tables. So you could see nulls in any of the columns, basically. So looking at this example of customers and orders, it is going to pull in everything from the customer table. It is going to pull in everything from the order table. If we have a customer that doesn't have an order, we will see null for the order ID. And if we had an error condition where we had an order that didn't have a customer, then we would see null as the customer name. Okay, but it's automatically going to pull in everything from both tables. We could try doing the employee one and see if that'll work. With the employee one, it will pull in all of the orders, even if there is no employee associated with the order. And it will pull in all employees, even though we may have an employee that did not place an order. Yep, and it doesn't like that. Some of these are coded behind the scenes, so you can't change them. But that is what that query should do. Oh, I should mention you can go into ssms and you should be able to run that. I'm going to pause a minute. Okay, so this should be using the Northwind database. I'm going to go ahead and copy that. And I launched ssms. Let me switch to Northwind over here. And let me paste. We'll see if it works here. And what does not, let's see, it does not like how we call what we call things. So it must be named a little different. Let's see if we can get this to run. Okay, so we have customers. Oh, we have no customer name. We have a contact name. Okay, and then we have orders. Actually, this isn't the one we wanted. We wanted the employee one, right? Let's try this one. All right, orders and employees. Here we've got employees, making sure, okay, the last name and first name is right. And then we've got orders. And we have order ID. Okay, let's see if this works. All right, so it's a full join. So it may only be showing us where they match. But in this case, if we did have any orders that were not associated with an employee, it would show null for the employee And if we had any employees that didn't place an order, it would show null for the order ID. There is a lot of data in that database. Alrighty, self-join. Self-join is where you join to itself. So a table is basically joined to that same table, which is kind of confusing. You have to use aliases for this. So if we joined the customer table to itself, maybe to determine customers from the same city, okay, then we could do this type of self-join. So we would be looking for the customer IDs that weren't the same, right? Because if they're the same, it's the same customer. So we would look for the customers that aren't the same, but we would want the city to be the same. Okay, so that is an example of a self-join. Okay, and then we get into unions. And basically all unions do is you've got two different selects from different tables. The columns have to be the same. And then basically a union combines them into one result set. Okay, and then there's things for you guys to practice. Accept and intersect kind of do the same thing, but if you use intersect, then it's going to look at the columns that you have from the first query and the columns from the second query and only show you the columns that match. Okay, and what accept does is it takes the columns from the one query and it basically kind of subtracts them out of the second query. Okay, so it creates an exception. And the other one that I want to talk about is a crossjoin. This is super important and is going to be on your certification exam. A crossjoin creates a really large table. It's called a Cartesian product. And when you create a crossjoin, it basically takes the two tables and it kind of multiplies them by each other. Okay, and so here is an example of a crossjoin. So with a crossjoin, you are going to have lots and lots of rows. And what you guys want to do when you are creating your queries is you should do explicit joins. You need to use the word join and you need to use the word on because then you know how it is joining your tables. Otherwise, you do not know. And it could be doing a cross join. All right, I'm going to show you why it's super important to specify the on clause, especially if you do implicit, which I don't recommend doing. Let's say we want to combine employees and projects. There are 9 employees and I think there's 8 projects. And then if we do a cross join, what it's going to do is it's going to take 9 times 8 and it's going to give us 72 rows. If we do an implicit join like this and we do not have an on clause, it does a cross join. That is something that you guys need to be aware of. So if I run this, we've got the results from the employee select. Then we've got the results from the project select. Then we have the cross join and we have the select with the implicit join. The cross join and the implicit have the exact same results. And if we go into messages, you can see that. We have 9 rows from employees, 8 from projects, and our 2 other selects came back with 72. Okay, so this little implicit join without the on clause does a cross join. Okay, so just be aware of that. That is something that's kind of tricky, and there is a question about that on the certification exam. It's going to come back and ask you how many rows it's going to retrieve, and it's going to look something like this. Okay, and this is a cross join, just another way of coding it. Okay, so that is the key points. After you finish that, you're going to do a textbook assignment that is more directive with the videos. So as you go through here, you will have the videos that you need to watch while you are completing the different tasks. And you'll get a pretty good feel for what the different joins do. And then you have a lab assignment where you are going to be creating your own joins. So definitely watch this video because as I mentioned earlier, the mistake that people make when they are doing their own joins is they don't pick the right column to join on. So the key for this to work is that you have to find a primary key in one table that is a foreign key in another table. And then you can join the tables. Okay? If you don't have that primary key, foreign key relationship, the join's not going to work. Okay, so that's the lab assignment. If you get stuck on that, let me know. I did give you some examples. I don't want you to do the exact same query as the example. Okay, it's an example and you guys are supposed to be making up your own so you can apply what you learn. However, if you wanted to do something similar, that would be okay. Once you finish the assignment, you're going to upload those SQL files to the Dropboxes, and then you can take the quiz. The quiz questions are similar to what you're going to see on the certification exam. So they are not, your vanilla true, false, multiple choice. There are all sorts of different question types. And unlike the certification, this is an open book test and there is no time limit. Your certification has a time limit and it is closed book. For this test, it is open book. You can take your time and you can actually take the test 3 different times and your highest score will be used. Okay, so when you're taking the test, kind of be aware that not all of the questions are going to be the same every time you take it because they're kind of coming from a pool, but you can take it 3 different times. And I would encourage you to do that because the more practice you have, the better you are going to be at answering these types of questions for your certification exam. Okay, so that's pretty much what we have going on this week. Under course resources, you'll notice that I've defined the terms in chapter 4 for you. There is a slideshow for you to watch if you want to. And then if you feel confused about anything that we covered, there are video links and you can go and watch a man with a very pleasant accent explaining these concepts to you. If you run into problems or have questions, let me know and have a great week.